So in this video, we're going to apply the washer method to find a volume of revolution. So this problem says, consider the region bounded by the parabola y equals 4 minus x squared, the line y equal 4, the line y equals 0, and the line x equal 3. Find the volume of the solid formed by rotating this region about the y-axis. So the region we're working with, it says the region bounded by the parabola, so that's this guy. And I know I don't need this part of the parabola because of the other bounding regions. It says the line y equal 4, which is right here. The line y equals 0, which is down here. And the line x equal 3. So the region in red is going to be the region. This region here is going to be the region that gets rotated around the y-axis, which means when we rotate it, this area in here is going to be missing. It's going to be an empty area, which makes, or empty volume, which makes this a washer method problem. We need to subtract off the piece that isn't going to be there. So with respect to the y-axis, because it's a y-axis revolution, the larger radius is going to be the radius for which you go out to the line x equal 3 if you're drawing your representative rectangle. And what you can see here is that we have a constant radius of 3, so x is always equal to 3. And right here we see that we have dy slices, so we're working with respect to the y-axis. With respect to the y-axis, we know that we're going to be, our limits of integration are going to run from 0 to 4 based on our bounding lines. And the inner radius, the smaller radius, so x, the larger radius, is just going to be that constant 3. The smaller radius from the washer method formula is going to be little r of x is going to be equal to, and it's going to be controlled by the parabola. So if I draw a representative rectangle based off that parabola, it's going to look like this, and you can see that's the smaller radius. The radii are still x coordinates, and the slices are still dy slices, and so we need to figure out this radius as a function of y, because we're going to be integrating with respect to the y-axis. So I have to go up to the parabola formula, which is y, or the equation, y equals 4 minus x squared. And I need to solve this for x, so I know x, the radius, right? X represents the horizontal distances. I need that radius as a function of y. So if I solve this for x, I'm going to get x squared equals 4 minus y by algebra. We're going to take the square root of both sides. We recognize that we usually do plus or minus the square root, but minus the square root would give me this half of the parabola, which I don't need. So we'll just keep the positive square root. So if I'm setting up my washer method formula, I'm just going to be taking and calculating my volume. Let's look at this two different ways, maybe. So I'll separate this so I can look at it from two viewpoints. So viewpoint 1 would be calculate my volume by taking pi times the integral. We're running from 0 to 4 on the y-axis because of the y-axis revolution. And we need the larger radius squared, but the larger radius is always equal to 3 because it's controlled by that line x equals 3. So it's going to be 3 squared minus parentheses the smaller radius, and the smaller radius is controlled by the parabola, which is x equals the square root of 4 minus y. So there's that radius, and we would need to square it. And then times the width of our disc or washers, which are dy's. And then it's just a matter of running the calculation through. So we get pi times the integral from 0 to 4. We can do some simplifying, so 3 squared is 9, minus the squaring will cancel the square rooting, and distribute the minus sign into the parentheses and combine like terms. So we're going to get 9 minus 4 is 5, minus minus plus a y dy, and then integrate. Integrating 5 with respect to y gives us 5y, plus integrating y squared with respect to y gives us 1/2 y squared, and the limits of integration are running from 0 to 4. If we were to plug in the lower limit of integration, we see that it's going to zero out, so we don't need to worry about it. We'll get minus a 0, so we'll just worry about plugging in the 4. So we get pi times 5 times 4 plus 1/2 times 4 squared, which is going to give us pi times 20 plus, and we get 1/2 of 4 squared is 1/2 of 16 is 8, and we get 28 pi, and it's going to be cubic units because it's a volume of revolution. So the other way we could have done this, maybe a little more thoughtfully without just jumping to use the formula, would be to think through the geometry of what's going on here. So if I look at the area, the volume of the bounded region revolved around the y-axis, one thing I could recognize is that if I revolve the line x equal 3, and I don't worry about the parabola initially, if I just revolve that around the x-axis, I'm just going to get a big cylinder, right? If I take this shape and revolve it around the y-axis, I get a cylinder of radius 3 and height 4. And I know how to calculate the volume of a cylinder. So I could say, hey, I'm going to find the volume from revolving the indicated region, but I'm going to first revolve the line x equal 3 on the interval from 0 to 4 around the y-axis, which just gives me a cylinder. And the volume of a cylinder is just pi times the square of the radius, but the radius is going to be 3 times the height, and the height of that cylinder is just 4. So instead of using calculus, I can just use the volume formula from geometry. And then I could say, once I get that volume, I'm going to need to subtract off. I'm going to need to subtract off this missing piece. I need to subtract off that. And that's just the volume I get when I revolve this parabola around the y-axis. So I could say minus, subtract off that volume. Well, it's going to be pi times r squared. Our integral is going to run from 0 to 4. Pi r squared, but r is going to be the square root of 4 minus y, right? Our radii are the x coordinates, which is just the square root of 4 minus y. We already calculated that. So here's the square root of 4 minus y. Square the radius, and then multiply by the width of each rectangle of revolution, which is just dy. And then we can grind this out. We get 3 squared is 9 times 4 is 36 pi from geometry, minus pi times the integral from 0 to 4. We square the square root. We just get a 4 minus y sitting in there, dy. It's already ready to integrate without any simplifying that we had to do here. So it's going to be minus pi times. Integrate 4 with respect to dy. We get 4y. Minus integrate y dy. We get 1/2 y squared. And this is going to run from 0 to 4. Equals 36 pi minus pi times, plug in 0, we're going to get 0. So I don't need to worry about the lower bound of integration because we'll just be subtracting a 0. Plug in the upper bound of integration. We get 4 times 4 minus 1/2 of 4 squared is just equal to 36 pi minus pi times 16 minus 4 squared is 16 divided by 2 is 8. So we just get 36 pi minus 16 minus 8 is 8 pi, which is still going to give us the 28 pi cubic units that we got doing it by utilizing the formula directly.